All right, so number 4 asks for us, and it says, according to the supplemental guide, which traits show a blending of genes? So remember, we talked about previously how dominant genes will show up when there's a homozygous dominant, so that's this column, and they also usually show up if there is a dominant gene in the heterozygous, and that's this column, and they do not show up when we have two recessive genes, which is this column. Okay, but what I want you to remember is that sometimes there is not a gene that is dominant nor recessive. It is a blend of genes. And so if you look here at this snippet of your supplemental guide, you see that this guy right here, the cleft in the chin, is the dominant trait. And so if you have a homozygous dominant, you're going to see an absence of the cleft in the chin. Same thing here. Again, if you have a heterozygous, that dominant is going to override the recessive and you're not going to see a cleft in chin. But if you have two recessive genes, that cleft in chin is going to be prominent. Now, hair, if you have curly hair with dominant homozygous gene, the curly hair is going to present itself. If you have um, recessive, mm, homozygous recessive, you are going to have straight hair. But if you notice here, if you have heterozygous, a dominant trait and a recessive trait, it is actually going to blend. So you're going to get a little bit of curly and a little bit of straight, resulting in wavy hair. Widow's peak is not a blending of gene. Notice that how when you have two homozygous dominant, you're going to have a widow's peak. When you have a heterozygous and a heterozygous with a dominant and a recessive, you are still going to show that dominant gene, but when you have two recessive genes. So the hair gene is a blend. The widow's peak is not a blend. The cleft in chin is not a blend. But looking down here at spacing of eyes, if you had two dominant homozygous genotype, sorry, if you had two dominant alleles creating a homozygous dominant genotype, you're going to end up with close together. If you have a homozygous recessive alleles paired together creating two lowercase e's, then you are going to have far apart. But notice how we have close together, normal distance, and far apart. So if you had a actual heterozygous genotype with a one dominant, one recessive, you're going to have a blend of far apart and close together, creating a normal distance. So in order to figure out all the genes that are blended, you are going to want to go through that supplemental guide and you're going to want to find the ones that are different in the middle that have a blend. So this one, not a blend because it's the same as the dominant. This one is a blend because it's not the same as a dominant. This one is not a blend because it is the same as the dominant. And this one is a blend because it is different from the dominant. So that is how you're going to look to find out how to find the blending of genes.